The mission of this lab has two purposes: to develop the most advanced technologies, to enhance the performance of structures, and also to increase the reliability, durability, and also we like to enhance the safety and minimize the life cycle cost of these structures. Second part of the mission is really we try to educate our students with the best knowledge of composites and structures or integrated material for the future. This structures lab started in 1984. I was a postdoctor with the Professor George Springer's. We work on composite material for aerospace because they're lightweight and high strength, and we would like to use this for the design of the aircraft. The current focus is on the multifunctional material. So what is a multifunctional material? Traditional material you design, you worry about how much load the structure can carry. We're concerned about if the structure has a sensing capability, or sensing is the health conditions. This is the class I teach. We make composite pieces like this, and the students will learn how to design it. In order to cure the material, once it's done, and taking it out from the autoclave. This is a composite piece made from this laboratory. Outside this leads here, a sensor to measure the defect or damage in the material. The students every year, they took the class and they really enjoyed it. One of the major focuses of this lab is to develop this large sensor network. To easily expand this material from very small scale to a very large scale into the material that can cover entire size of the aircraft.
This is approximately 1.5 inches square, and it was stretched out to cover approximately a square foot. These materials are piezoelectric. Strain them, they will create a voltage, or when you apply a voltage to them, they will strain. Here I have two wafers you can see. This one has gold on it. So here you can see screen printed piezoelectric elements that have been deposited directly on a gold layer.
For that also we have a capability to make a carbon nanotube. The nano sensors can be integrated into composites into the network.
This is a composite panel from a Boeing 777 aircraft. Let's assume we have a foreign object impact on the middle of this structure. So now the system is taking the data in real time, and you see first the distribution of the impact energy, as can be seen here. We have this panel, we have here an active system installed. So this sticky tape just introduces any change, and after any damage occurs, will give us the possibility to create this kind of diagnostic image.
So here we can see the actuation signal and the wave starts propagating.
Also in the lab, we study the energy of absorption of composite material. For instance, this material is made of carbon fibers, and this is made of Kevlar fiber. And this material fail by fractures on fibers. This is actually, you can see, due to deformations.
For example, the carbon fiber, you can see lots of fiber fracture and brittle failure of the matrix. Kevlar is very ductile compared to carbon.
And we are trying to use this to design automobile applications, and also for the helicopter, for the landing gear.
We take data from the sensors, and we also X-ray the sample to see the damage, to try to monitor the state of the structure. We use an MTS machine, which does fatigue experiments. And what I do is I load it in fatigue. So basically I'm cycling like this on the machine. So what we want to do with that, to be able to understand and interpret what the sensor is saying, you can see a little bit of the damage right here, the lamination. And so if you take the X-ray, there's even more damage than you would think. The big picture of this is that if you have it on, say, an airplane wing, say you get hit by a bird and you know that there's certain damage, you'll know what happens to the wing if you need to land right now or if you need to maintain it in 3 flights.
We cover a very wide range of disciplines. We have students come from material science and electric engineering. We have students from the aeroastro. All right, there's some of those area of structure of some material, and we do have people also from civil engineering, and some have come from totally different background. Yeah, this is multidisciplinary area. Currently, we have about 20 students, well, roughly about 85 students graduate with a PhD degree.